This is something that I saw that I noticed that isn't discussed in mainstream publications. Says here the title of this paper is Planet Formation Theories in the Age of Statistically Insignificant Data. The abstract goes as such. Planet formation theories were invented before any statistically significant data was obtained. This is made apparent because before the 1980s, there was only one solar system, our own. This issue will be addressed in simple terms. The purpose of statistics is to find patterns in data, and the more data you have, the higher likelihood a researcher can draw up meaningful patterns. Unfortunately, this is a huge issue in astronomy and astrophysics. Before the 1980s, there was only one system to take any meaningful data out of, yet there were over 200 billion stars, or potential systems, that could host planets in the galaxy. Therefore, drawing up any type of prediction concerning planets and their formation when the sample size was 1 out of 200 billion was extremely likely to lead to false interpretation. The realization lies in the simple fact that just because something shows a pattern, all the planets close to the same axial plane around the Sun, does not mean it is significant, especially when the sample size is 1 out of 200 billion. That would be like only looking at the winners of a large lottery with the odds of 262 million to 1 and saying the odds are, well, better than 1 to 1. Those winning individuals are not representative to the overall odds whatsoever. So why did astronomers take an even smaller sample and try to force it to explain literally everything to do with planet formation when they essentially had no data? And the way I look at it is, it isn't that they didn't have enough data. It's the human mind, when it doesn't have enough information available, it kind of just forces something to be true without all the information being there. Like, for instance, if you're to be talking to a friend and they don't return your phone calls or you don't get text messages from them, you can draw up scenarios saying like, well, they don't want to talk to me, or, you know, they think they're, whatever. You make whatever scenario you want up in your mind, and that becomes true when you haven't received any message or phone call from them at all. You don't know what's going on. And it's like with moms, like if their kid is like out a little too late on like a Friday or Saturday night, an overprotective mom would think like, oh, they're dead in a ditch somewhere, or they got into a car accident, but really they're just partying and they forgot to check in, or they're staying out a little too late. But that's essentially what astronomers did before the 1980s roll around, is that they looked at the solar system for what it is, and they assumed that this is representative of 200 billion potential systems. So now they're going out with their telescopes and they're finding that all these systems are, they're not representative. The system that we have here isn't representative at all. And then they're constantly confused. But that shouldn't be a surprise, When you look at the statistics of it, you have a sample size of 1 out of 200 billion. Of course there's going to be some problems. You can't take that little bit of information and draw completely sweeping conclusions from it. But that's what they did, and the time for that is over now. Now we're finding stars that are intermediate size between star and planet, and they have brown dwarfs now, which were also discovered in the 80s. And now we're going to be playing a big game of connect the dots, because stars and planets were never different objects to begin with. That was based off the idea that the solar system was representative. It's not at all. It's a very unique system. All right. Well, I think that sums it up. I'll link this paper to the bottom of the page. All right, y'all. Later.